we were talking about this alluvium and then alluvial fans and then terraces, and we have this Tuscan formation. So we're looking at these different geomorphic provinces, right? Different geomorphic landforms and stuff. And what we want to think about is how that geomorphology, intersects with soil forming processes that then are reflected in the morphology, So what we're going to focus on today is moving up this andesitic lahar material, so that volcanic material, and we're going to look at how climate, which is one of the soil forming factors, how it interfaces with taxonomy by looking at two different soil orders, and how it interfaces with the morphology, But what I think it's really cool is the story is expansive across the landscape. We're going to focus in on a little part of the landscape today, but if you look out across the great Sacramento River Valley, and we're coming up along these terraces and fans, all these different geomorphic and geologic processes are interfacing then with soil formation, with taxonomy, and where people decide to live. And it's just an interesting interface. And we're going to zoom in on just one part of the story, but the story is expansive. And thank you, Garrett, for taking us out here.
Oh, it's awesome. You can see the water gap to the east where there was a big stratocone right over there, like 20 miles away, 15, 18, 20 miles away. There's a stratocone, and there was a few of them on the horizon going north. One at Battle, at Mineral, a couple around Lassen, like all that kind of stuff.
So then when we were coming up, you were starting to talk about, there's the recent Sacramento Big Chico Creek alluvium.
That's all the trees.
Right, and then where the university is and the town, is that on like
on the alluvium? No, it's on the alluvium.
Okay.
It's all the alluvium.
Because then when
you can see all the trees like that,
yeah,
and then you can see the grass flat on both sides. That's the remnants of the terrace.
See the fan right there.
Yeah,
right?
and that's the remnants of the terrace of this thing eroding down into this material that was laid down in the last 1.5 million years. So like 2.5 million years ago, there was a big ass volcano over there, and this was more like probably some rolling hills or a low plain going to this giant cone, and a bunch of them. And then as just like you think about modern day Mount Hood versus Portland kind of style, and then at whatever mechanism turned on the eruption and volcanic eruptions on glaciers, and these stratocones were decomposing and sending down this material that you could see the big planar surface of the shit that had rolled down and piled up.
So the Tuscan, because I always thought of this stuff as being basalt around here when I drove through it, but
No.
this is all andesitic flow material.
Yep.
It's flowing down. You can
Hot
see
and cold
Yeah.
fluid materials. By the time we get down here, probably a little more reworking, so it would have been like its own kind
There's
of
some
part.
big blocks though.
Oh yeah.
Yeah.
And so that's where the variation in soil depth that I talked about last night carries up. You'll get on one unit that's a little more amenable to weathering, and you'll get a deeper, more productive soil. And right next to it might be a boundary with a different flow characteristic in the lahar, and it doesn't want to weather.
You think some of it was straight lahar material and some of it was actual flow material?
There's
This stuff on the cap almost looks like flow material, right?
it's just a cobbly version of it. It goes all the way down, and below this is the Chico sandstone, a marine sandstone from previous time, and I don't
Great
have that.
Valley type stuff? Or?
Probably, and that's the stuff that I never really learned.
So recent alluvium, you can see where some of the croplands are. Then the treed sort of alluvial fan area. But then when we were driving up, I was taking a little video, and you could see there was some of that cobbly older terrace material.
Down at the bottom.
Down at the bottom, right before we hit the slope.
That's the terrace.
Okay.
That's reworked material of this.
Right. So there's just a small terrace remnant, and the rest is fan.
Yeah, you can see it. So it's actually a really good spot that I hadn't thought about till right now. And if we were up there in the future, or if we'd get a picture from there, it might not work as well. But you can see to the north. So you see the big tree alluvial fan, Chico City of Trees, Valley Oak Savannah.
Right.
Bidwell had been all over California, and supposedly, as the story goes, he was taking some people north to Oregon, and he came across the alluvial fan of Big Chico and Butte Creeks and was like, wow, this is different than other places.
Yeah.
The trees were bigger, there was more grizzly bear, more salmon, that kind of stuff. So that's why he got his rancho. He got gold in Bidwell's bar. He was able to buy different pieces of his rancho, which was most of the alluvial fan of Big Chico Creek.
Right.
Just to the south is where Butte Creek comes in, and it's a bigger fan, and then that butts up to the Butte Sink, which is where the vertisol rice soils in the basin is. So you can see to the north, the big flat yellow grass, that's all terrace.
Terrace, yeah, I can
terrace
see it.
Of this material that got washed into the valley and got reworked as the alluvium of the erosion of the stuff we're standing on, right?
And then
in the last million years.
Right. And then the whole, that's a Holocene age alluvial fan on top of that.
Pretty much. I mean, nobody's really, that's a question that I'm really interested in moving forward. There's a bunch of recent, not EM, but like kind of subsurface radar work that's going on to look at characterizing the aquifer system and the stratigraphy of this part of the valley. But if logic holds up, and 5, 7, 8,000 years ago, sea level was 150 feet or more lower than it is now, there's not a alluvial fan sitting right there. There's a canyon that's going out to some other canyon
with some terraces along the sides.
Right. And then once the sea level rose, it allowed. I mean, the delta supposedly only 4,000, 5,000, 8,000, 6,000, in that range old, because the water level's so low. As sea level rose, the delta started to pile up because the water wasn't just ripping out to the fairlawns anymore. They said you could walk to the fairlawns pretty damn close in that in the last 20,000 for sure, right? And so all that material had to pile up since the sea level started to rise, right? Because the water was slowing down, the sediment was slowing down. It wasn't just flowing out to the ocean, not metaphorically speaking, but.
Right.
So when we go to our farm, we have a clear buried profile, at least I think it is, with the buried horizon and then cobbly stuff on top of it. So you can see that repeated rise and then the deposition and the development of the fan, right? Which now has been smoothed over. But with the LiDAR that we got from the campfire, I think we're gonna be able to see some stuff that doesn't show up on the traditional topos, and some of that story is gonna be able to kind of unfold, along with this subsurface geophysical stuff that they're doing to think about the aquifer systems. We have there's supposed to be there's kind of three main units of Tuscan, A, B, and C. The C is the sandier unit, the reworked material, and that's the prime aquifer recharge and withdrawal spot for groundwater pumping. So they've been mapping that stuff out, trying to figure it out, because we're a water exporter in Butte County, right? Like we don't have a huge population, we have a lot of ag, but a lot of our water goes out because that's how it works. So, long story short, terrace. In a future visit, we're going to go out to our soil zoo at the University Rangeland. 5 soil orders in 150 meters.
Nice. From,
inceptisol, mollisol, vertisol, alphasol, and there's one other one out there I think that we could easily pick up, all in an inset version of a geomorphic sequence on that surface. So something that cut into it. And there's contemporary geomorphic stuff in an ephemeral stream, seasonal stream, and the terraces. So this cut into the parent material for the terraces, and the range spot has the terraces that have been eroded and a totally different sequence inset in that. Super cool. Really cool microtopography, very subtle, and very different soils in a very short spot. So let's do it. We're going to go up here a little bit farther, about another mile. We're going to go up on this ridge, and I'll point out the window. There's a spot where it's clear enough. You can see Lassen right up.
Yeah, and what I think is so important about what you're talking about is how you need to know the geomorphology to know what the parent materials are. And
it helps.
It really helps to inform
later
how the soil forming processes work, because you have to know the parent material, and then we're going to move through on one parent material and have a climo sequence today. But knowing the geomorphology helps to know the parent material,
very much
which then is going to, remember, know your site, know your soil.
Well, we talked about this last night when we were getting back together, and just the idea that the morphology of the soil is important, and understanding how to characterize those features, but being able to roll up on a site and having thought about it in advance and having a place for it, using the soil forming factors model and topography and parent material as these two important variables that I always tell my students, You're never going to get dropped out of an airplane and be expected to characterize the soil and know what it is, because that's not the process. The process is leading up into going to that pit for a reason and digging a hole there to test your model, not just to go out and do some mechanical characterization. So as you're driving up in the car, the van, you're going to the event, hopefully by that time you've thought about what is the province you're in and why, and you're having that discussion with your mates or your peers or your instructor, whoever.
Internal dialogue.
Yeah, to try to place that location on the earth and in the bigger picture of not just does it have a BT and what's the texture.
Yeah.
So,
Garrett, I'm so glad you took us out here, man.
Boom, let's do it.